This is question 3, part 1. A system consists of a bicycle and cyclist traveling at a constant velocity along a horizontal road. Okay. Part 1. State the value of the net force acting on the cyclist. The guy's moving at a constant velocity, and so he's not accelerating in any direction, so the net force has to be 0. Okay. And the key is constant velocity. All right. Part 2. On a diagram, draw labeled arrows to represent the vertical forces acting on the bicycle. All right. So I color coded them here. F pedals, which is the force of him pushing down on the pedals, is in red. Okay, and that's a shorter arrow here. And the force of gravity, it comes off of the center of gravity of the bike here. All right, and that goes downward as well. All right, and if I add the force of gravity to the force of pedals, the lengths of those arrows are about equal to the lengths of these two normal force arrows, or they should be, and they look about right to me, because the normal force acts is equal and opposite to the force of gravity plus the force of the pedals. Otherwise, the bike would fly in the air or crash through the earth. All right, it's not doing that. Okay, with reference to horizontal forces acting on the system, explain why the system is traveling at a constant velocity. Okay, so in this case, and I'm just going to do it in red here, the drag, which is the air resistance, okay, let me just cross that out. Drag plus friction, tires, friction on the tires, equals thrust. This is why in bike races there's a rule against drafting, so you can't ride right behind someone else, and people do that a lot because the person in front's blocking all the air that's blowing against you, and you're basically like biking in a gym where there's no air resistance and you're standing still on a treadmill bike. So in this case, the drag is equal to the thrust, therefore the net force is 0 and there's no acceleration. Okay, see you in part 2 of this video, or this question.